In this video, we'll use the advanced 3 steps to sketch method to get a good sketch of a shifted tangent graph, y equals 2 tangent of 3x minus 1. So here's our outline and a reminder of our equation with a grid. And the first thing we should notice about this equation is that we do have a vertical shift. That's this minus 1. So let's remind ourselves of the general form for a shifted tangent equation. That's y equals a tangent bx minus c plus d. Okay, so now we can jump into the method, and we'll start with step 1, which is to find our essentials. And we'll focus in on our base graph first, label our axes, and then we'll tackle the shift in this case, and the asymptotes equation. So our base graph, we need to identify a, which is the coefficient in front of tangent, so that's 2. And we'll use this value for our curve setting points when we plot our base pattern in our final graph. Okay, that's like the vertical stretch factor. So if you compared this graph to the graph of y equals tangent x, the parent graph, you would see that the graph has been vertically stretched out by a factor of 2. Okay, then we see b. B is the coefficient in front of x, so in this case that's 3. That tells us there will be 3 cycles of our graph between 0 and pi, and it also helps us calculate the period, and for tangent we do that, pi divided by b. So our period, or the length of one horizontal cycle, will be pi over 3. Okay, great. Now we can choose how we label our axes. So for the horizontal axis, we are very particular, and we want to get it so that each point in our base pattern aligns nicely with our horizontal tick marks. That just makes for a nice clean graph, and we can be sure it's really accurate. So we'll take our period and divide by 4, and that's what we'll use to label our horizontal tick marks. So we have pi over 3 divided by 4. It might help you to write out times 1/4 instead, just a little easier to look at. So we'll be labeling counting by pi over 12. For our vertical tick marks, we usually can just use 1, and that'll work very nicely. Okay, so let's pause for a moment to label the axes. So horizontally, we're labeling counting by 1 pi over 12, 2 pi over 12, which reduces to pi over 6, 3 pi over 12, which reduces to pi over 4, and 4 pi over 12, which reduces to pi over 3. And of course, the next will be 5 pi over 12. So we'll label very similarly in the negative direction, just of course with negative signs. All right, got that taken care of. And now we'll label our vertical axis counting by 1s. All right. So now we can move on to identifying the shifts. Notice that the only input in the tangent function is the 3x. We do not have a c term, so we don't have a phase shift or a horizontal shift here. So we don't have to worry about horizontal movement, at least not shifting. And then we said that we have a vertical shift. That minus 1 is our key. That's our d term. So minus 1 is d, and that tells us our function will move down 1. Okay. We'll tackle that in step 3. Finally, let's go ahead and find the asymptotes equation so that when we have our final graph sketched, we can use that to double check. So all you have to do to find the asymptotes is take your inputs of the tangent function and set them equal to pi over 2 plus pi k, which are the parent asymptotes. Those are the asymptotes of y equals tangent x. So here are the inputs. I'm going to do a little scratch work up near the top. We'll have 3x equals to pi over 2 plus pi k. And remember, k is just an integer, and you substitute in different integers to get different asymptotes all along your tangent graph. And this is a really neat way to represent all of the asymptotes at once. If you need any more help with this, there will be a link in the video description that takes you through. You can find several examples and a more detailed explanation of this method. But for this, we see we have 3x set equal to pi over 2 plus pi k. And now we just need to solve for x. So divide both sides by 3. So make sure you divide every term by 3. If you even want to show that, you can do that. divided by 3, divided by 3. So our asymptotes equation will be x equals pi over 6 plus pi over 3k. All right, so just looking at this, we see if we let k equal 0, and I'm just copying this down into the space for asymptotes equation. If you let k equal 0, we should have an asymptote at pi over 6 on our final graph. You can find other asymptotes by letting k equal 1, 2, -1, -2, and so on. But notice that the asymptotes, that plus pi over 3k, they happen once a cycle, and so your plus pi over 3k is really just the plus the period k. So we should feel even more confident that that equation is working for us well. So now we're ready to move on to step 2. We will plot our base pattern lightly, or in a different color. I'll use light blue. So this won't be our final graph. We'll do the shifts in the next step. But we can plot this base pattern for tangent. It'll be 0, point, asymptote, point. And we know it's not reflected because we did not have a negative sign in front of our equation. So lightly, we mark our first x-intercept at the origin. Our curve shaping point will happen at the next horizontal tick mark to the right. And the y-coordinate will just be the value of a, so 2. So we'll have a curve shaping point at pi over 12, comma 2. All right, then the next in the pattern is the vertical asymptote, so that'll happen at the next tick mark. Remember doing this lightly because we do have our shifts to take care of in a minute. And then our final point in the pattern will be our final curve shaping point, and that'll happen at pi over 4. And the value for the y-coordinate will just be the opposite of a, so -2. All right, let's close out our pattern with what would be the first point in the next cycle of the graph, as an x-intercept at pi over 3. And this is our base pattern. So now we can switch to our final color. I'll switch to green. And we can apply our shifts. So in this case, it's pretty easy. Just take each of those light blue points and shift them down 1. If you had a shift, say, right pi over 4 or left pi over 6, you could do that at the same time. But since all we have to do here is shift each of these points down 1, let's do that. Okay, so we have darkened points for our final points, and these are in green. When the asymptote moves, a vertical asymptote moving down doesn't affect it. It stays right there at x equals pi over 6. We have our final points down 1, and then we can sketch our graph in. So you can see that vertical stretch here, a factor of 2. And this is one cycle of our tangent graph. Now all you have to do is repeat the pattern, and so you can do that for as many times as you need. We see we really only have space to repeat one more point here going right, but you could see another asymptote would happen at 6 pi over 12, or that would reduce to pi over 2. And that, if you plugged in k equals 1, would be what your asymptotes equation would give. All right, so let's copy the pattern in the negative direction. Okay, and copying one more cycle of the pattern. Okay, and we'll sketch those curves in. All right, so we have almost 3 cycles of our tangent graph here. Before we go, one nice thing to notice is if we were to let k equal -1, let's plug that into our asymptotes equation and show what happens there. So we'd have pi over 6 plus pi over 3 times -1. And so we would want to get a common denominator here. We would have negative pi over 3 turning into -2 pi over 6. And so you see that this equation generates the asymptote at negative pi over 6 when we plug in -1 for k. So just looking at our graph, here's the asymptote generated. We just said by k equals -1. We saw that the one at pi over 6 happens when k is 0. And so you can imagine if we kept going in the other directions, as you plug in increasing values for k, you'd get the ones moving right, and decreasing values for k, you'd get the next ones to the left. So that's just a neat way to better understand the asymptotes equation. Hopefully this helped you understand the advanced 3 steps to sketch method and how you can use it to get a really nice tangent graph. Check out the video description. You'll see links for more examples for graphing tangent, more examples with finding the asymptotes equation and working with that, and some examples of other trig functions. Thanks for watching.